Hello everyone, in this video I wanted to give a short summary of a little project which my friend Rifat Kamal and I have worked on some time ago. The initial vague goal of the project was to make use of the programmable Tello Drone to do something cool with it. I would recommend anyone interested in drones to start with this drone. I have not tried to play around with other programmable drones, but I did enjoy this one and I found the Python API very beginner friendly. After figuring out the basic controls, we decided to go for a face follower. So because we can control the drone in 3 planar directions and 1 rotational direction, we had the drone draw a bounding box around a detected face, and based on the location of that bounding box within the drone's frame, we had the drone move in a certain direction. As a side note, the face detection part was done by implementing the Haar Cascade, which is a relatively simple yet effective face detection machine learning algorithm. I'll put a link in the description of this video if you want to learn more about it. Going back to figuring out where the drone moves. So if the bounding box that we have around the head, we already said, is detected, let's say that bounding box is on the left side of the frame, then the drone rotates leftwards until the box is somewhere in the middle of the drone's frame. Of course, it's the same story for the y-axis. Depending on if the face is too high or too low, then the drone will readjust its height accordingly. And finally, how does the drone know to move forwards or backwards? We simply calculate the area of the bounding box at each frame. We have decided on a range of area values which are just right in terms of distance, and any value we get outside of that range will force the drone to move. So if we have a bounding box which is too large, then this means that the drone is too close and it will move back. Similarly, if the bounding box is very small, that is indicative of a large distance between the drone and the target, hence making the drone move forward towards the face. Furthermore, we have implemented a very simple PID controller in order to regulate and adjust the speed at which the drone advances or retreats. Simply put, if the bounding box is very small, then the drone will move forward faster. As the drone approaches the face and the bounding box increases in size, the drone will keep advancing, but it will slow down as the box grows in size. The speed of the drone is a function of the difference between the bounding box size desired and its current size. The second thing we did, although I have very little footage to show this, is a face recognizer program. So we got Python to analyze and encode an image of myself, and what the imported library basically did is represent my face with a bunch of numbers, 128 of them to be precise. With these measurements, the drone can now recognize me. The thing I was going for next is to combine the two programs, the face follower and the face recognition program, to have the drone act as a surveillance drone. This drone flies up and rotates non-stop until it detects an intruder. There is a folder with the faces of quote-unquote the allies. Any face which is not recognized to be an ally is automatically labeled as an intruder, and an image of the intruder is taken. A list of the intruders can thus be made. Unfortunately, the drone died on me midway into this part of the project. The possibilities, in my opinion, are really endless with this drone, but we do live in a physical world, and there is a limit to how many times this $100 drone can hit a wall and fall.
Okay, starting it.
Turn on the video.
Yeah, I already did that. Okay, it's running.
Does it see me?
Nope, you're too far. It doesn't see anything. I think you have to get closer. Yeah, okay, now it sees you.
What a guy. Come up, come up, come up, come up.